Okay, yeah. Good afternoon, everybody. Great to see you all back for online training day 2. So hope you found yesterday's session insightful and have some time to explore what we covered. So today we're going to focus a bit deeper on the plugin utilization. All right, let's jump right in. So here's a quick look at what we have planned for today. After the opening, we'll start by reviewing what we couldn't cover yesterday briefly. So for those attending today first, please bear with us as we first go over the analysis and design part of the PSC composite bridge. Next, as scheduled, we'll cover group pile, PY curve, which is related to soil structure interaction, and Debond Made easy plugin accordingly. Also, we'll wrap up with a session with a Q&A session today as well. And so for those who couldn't join yesterday, here's a quick reminder about the 14-day free trial for MIDAS Civil and X. So you can basically activate it using the protection key shown here. Which provides access for 2 weeks after training as well. And please enter or take a screenshot. We'll give you a moment. All right, let's move on. So the material shown here are what we'll be using for today's training. You should have received them in the reminder email sent earlier, but if anyone has not downloaded them yet, no worries. I'll drop the link in the chat now. So please make sure to download the file before we get started. Just give me a moment, please. And along with the EU webinar I mentioned yesterday, there's another session on March 19th covering the integration between Grasshopper and the Civil NX. It will be held at 8 p.m. as of Sydney time, and we'll go over the features like the easier way to integrate tendon profile or the construction stage into Civil NX using Grasshopper in detail. So if you're interested in the streamlining your modeling process, make sure to check it out. You can also scan the QR code here to get more details right away. So feel free to give it a look. Next, here are some common account-related questions that you might come across while using our service. So the MIDAS support site provides not only just technical support, but also various training materials. So to use the service, make sure your account has been converted to an email-based login. So if you don't know how to get a technical support or face any issues with email conversion and anything related to account, please check the details on screen and reach out to us if needed. So this is a really important one. So after today's session, you'll get a satisfaction survey through the email in about an hour. So please take a moment to fill this out because we're genuinely looking to tailor the next online training session based on the feedback from the survey and make it truly beneficial when we hold the separate session with each company. So that's it for me. So, all right, now I'll hand it over to Pranav, who will guide you through the training. Pranav, please go ahead.
Thank you, Eric.
No
Hello,
worries.
everyone, and welcome to this second day training series. So I think Eric pretty much covered the agenda for today. So I will right away jump into our training session. So again, as mentioned, we could not complete the results parts in yesterday's session. So today's session agenda would be, we'll first uh, finish with the result generation, Excel or PSC design result generation, and then we'll move on to the API plugins. So I hope everyone analyzed their model. So for those who have attended yesterday's session, we have generated this model, which I'm highlighting on the screen. A 3-span continuous PSC structure with substructure and structure was generated, and we have analyzed in yesterday's session. So in today's session, we'll first start with the moving load combinations. So, okay. I hope everyone is ready with the model and they have analyzed it, and we are in the post-processing mode of the model. So first we will generate load combinations. In MIDAS, load combinations can be generated even in the post-processing state. So in the results, we can go to load combinations. Now everyone can start following the same steps in your respective screens. So I'll just delete these load combinations first. So if we go to load combinations, we can see there are various tabs: general steel design, concrete design, SRC, and composite steel girder design. We have all the options for design. Since in today's session we are going to focus on PSC design, we will generate our load combinations in concrete design tab. You have to generate your designs in respective tab according to the design which you want to conduct. So we are going to conduct a PSC concrete design. Hence, in the concrete design, we can obviously manually add these combinations, but we will use the auto generation feature for today's session. So we can go to auto generation, select our code, which is AS 1500.2 2017. Select both the factors, which is reduce safety and increased safety factors, and click on OK. So this will quickly generate you the load combinations for the loads with which is in your model. So we can see strength conditions and serviceability conditions. And description of each load can also be observed in the description tab. So what are the factors? Or else you can obviously observe those load factors in the column adjacent to it. So we can close this. So again, we'll observe few results first, and then we'll move in the design part. So in the reactions, reaction forces, we'll first observe the reactions in first construction stage. We'll select FZ, turn on legends, turn on values, and click on apply. So we can see in the legends, it is still in the exponential format. So we can change it to a fixed format. So click on 3 dots besides legend. All the formatting related changes to increase or decrease the number of decimal points, everything in these 3 dots besides appropriate title can be accessed and changed. Then in stage 2, we can see the superstructure is activated and the bearing reactions or the support reactions have increased. We can also view the max and minimum value only. So in this 3 dots beside values, just view max and min. Press OK. We can observe this is absolute max. Let's say max and min values. Okay, max and min. And we can view the ultimate maximum and minimum values on our screen. These values are the same, hence all the values are being highlighted. 3-2. And even final as well. This min max option in the drop down menu will give us all an envelope of all the minimum maximum values for our construction stages. And in the post CS, we can see all the load combinations. So for moving load, CL, CB1, these are generated by the code and so on. We can check these values in detail in later stage. Okay, now let's look at the deformations. So deformation contour. Again, we'll go to first stage. apply a few settings. So I'm going to observe deformations in the Z direction. I don't want any values. The legends are fine. Okay. We can see in the legends, these are still 0,0. We'll change the units to mm because the units are in meters. Hence the value, we cannot see any values. Change it to mm and we can see some deformation values. Just turn on the deform so we can see the deformed shape as well. Now stage 2. Okay. We can see this is upward deformation because we have applied pre-stressing and activated the superstructure. In the similar fashion, we can check deformations in other stages as well. All right. Now let's look at some bending moments. So under force beam diagrams, again, let's go to the first construction stage and check and apply. We can see bending moment diagram for this stage. Then solid fill so that we can observe more. To change the units again, kilonewton meter, and yes. In stage 2, use bending moment diagrams again because this is due to pre-stressing and sulfate is activated. So let's see just the weight of the sulfate in this stage 2. We can click on dead load. It will behave as a simple support structure. Then stage 3 is where the slab is activated. I'll check on summation. Similarly, we can also check on creep primary, tendon primary, or shrinkage primary options and secondary values as well. Let's check one of the other values in post CS, which is the maximum load for moving, maximum moment for moving load. So we'll select this MV max represents our envelope of loads for each element. It is not a single static position of vehicle. To elaborate further, in order to obtain maximum movement in this particular element, my vehicle position would be, let's say, position 1. In an element adjacent to it, my vehicle position will be position 2. So it is an envelope of moving load. It is not a single placement of moving load. Now, what we can do is from this, we can identify what is our critical element for the superstructure. So critical element for movement. So what we will do is we'll just, okay, let's do one thing. Turn on the tree menu to the right hand side. We'll go to works. Just we want to turn on the girder elements because this pier cap is having maximum movement in this case. I just want to view the maximum movement in the girders. So I'll just double click this part and I'll click activate. So these will select all the composite precast sections. Okay. Yeah. Since the model is too big, it will take some time, but depending upon your system's configuration, if it is a pretty heavy system, then it should be all right. You should not face this saving issue. Okay, so I'll click on active and we can see element 1813 is having the maximum movement. So if I just type in 1813 and enter, we can identify this is the element for the maximum movement, which is around 128.29. Now let's observe vehicle position at the same element and just have a look where the vehicle lies. So again, what we'll do first, let's active all. Now we'll go to results, moving tracer and beam forces. So you can observe vehicle position for various outputs. So elastic link is the recent addition in the 2025 version of the software. For those who are using a previous version, you would not find elastic link, but for the 25 version, this elastic link option is present. Okay, so but now we are interested in element 1813 and the vehicle position. Click on apply. Yeah. So now this is the vehicle position such that this 128.29 moment is observed at element 1813. You can see this is the same arrangement for a B double vehicle. This is B double vehicle axles. This red dot will indicate me maximum movement location, and this blue dot will indicate me minimum movement location for this vehicular placement. And these are the ordinates. As I mentioned, in MIDAS, moving load is based on influence line diagram. So these are the ordinates of the influence line. All right. So now after this, I think we have covered all the results. Now we can start with the design part. So an important thing for design is you need to have load combinations in order to carry out design. Software will not pick the loads which are defined in the static, which are defined under static loads. We need to create some combinations, and then the software will pick these loads and use them in the design parameters. So make sure you have auto-generated these loads. Then we can go to the design tab, and from the drop down, select PSC design. Select Australian standard, design code option. So nominal aggregate size as per clause 8.2.4.2, we have to provide a parameter. I'm going to use the default value for now. Regarding code project specifications, you can use your own values. Crack control. So maximum increment of stress, again, you have to assess your own value parameter and provide it over here. I'm going to select it because in ULS I want to check all these safety parameters, and in SLS I'm going to check the control of cracking. Click on OK. Then design parameters. So since we have auto generated it, this combination would be checked at the transfer stage. So there is a stress check at transfer stage. So for this combination, the stress would be checked against. And modify material. So I think you need to enter these properties. So again, re-enter the same properties which we have entered in the model. So under girder AS17, grade should be C50, compressive strength at transfer. So this is the limiting stress which you can provide so that the software will check against this limiting stress. Rebar, so provide AS17 in rebar and D500L. Similarly, input the values for slab as well. So concrete material selection AS17 C40. Rebar selection again AS77 D500L in both the rebar boxes. Can modify. Once you click on modify, you can see the values fixed for this particular name of the concrete. The reason behind we need to re-enter the values over here is if there is any, if a certain check is not passing, if it is failing, we can change the grade over here and check the particular check is safe or not. We need not run the analysis again if we change the material over here, but once we determine that if we increase the grade of concrete, our particular check is okay, then we can change it in the material properties and rerun the analysis. I agree, the values would not be same because the elasticity would change, but it would be a small change. With this, you can have a quick look if for a capacity of section is my safety check okay or not. Therefore, we need to re-enter the values over here. Now close this dialog box. We'll go to design position. So design position are the elements which we need to conduct the design on. It is recommended to select a few elements from our model because it can take some time to carry out the design. So we are going to select. So we have identified 1813 is the maximum load for moving load. So we are going to select the same span where 1813 is included. So the numbers would be So in here you can type 1803 to 1827 and press enter. So it will select all the elements between 1802 and 1827. So total 26 elements are. So if you hover your mouse over this bar, you can see number of selected elements are 26. And you can check the values in the tree menu. Either you want the moment directions to be calculated just for I section or J section or both the ends of the. I'm going to choose both the ends. Same goes for shear and press apply. So I have entered 1802 to 1827. Press enter, and in design position, I've pressed apply. In this three dots besides design position, you can have a look at the elements which you have selected for the design purpose. Let's go back to now output position. So in design position, software will design for all the loads, all the elements. But output position, we can also obtain an Excel report from the software. It is like a sample calculation sheet. We can verify, check the clauses, check the formulas and everything. A detailed report can also be generated. Again, if we enter all of these elements, it would take a lot of amount of time to generate the Excel report. So it is recommended for Excel report, just select a few elements. In our today's session, I'm going to select only a single element, which is 1813 element. This is just for the Excel report generation. Design will be carried out for all 26 elements which you have entered previously, but for Excel, only these elements would be, for Excel report, only these elements would be generated. Okay, you can view at various options and click on apply. Again, you can see the three dots and only 1813 is included in position for output. In output position and under design position, three dots, we can see 26 elements starting from 1802 to 1827 are included. So once you have defined this, we are complete with the definition. You just press on this perform design. In the command window below, you can have a look at the status. Once the design is complete, it will give me an output that the design is completed. Okay, it will take some time. Until then, if you have any questions, please type them in the chat box. Once the design is completed, then we will start with the API plugins. So I'm expecting at 12:30 we'll start with our first plugin, which is group pile plugin. So the very first plugin would be from the marketplace of Civil NX. So in total we are going to try 3 plugins today. First will be from the marketplace. Other 2 plugins would be from the materials which was shared in the group chat by Eric. So make sure you download those materials. We are going to use PY curves automated plugin and debonding length plugin. Okay. The analysis or the design is complete. So we can see in this command window, generation of data for PSC design has been successfully completed. Okay. Now we can go to design result table. We can check flexural strength, IJ, positive, negative. We can see few elements are failing. So we can identify the root cause, either increase the reinforcement or increase the concrete section, increase the grade or increase the concrete section by assessing these parameters. We can also view this graphically. So in PSC result diagram, if I click on apply, this all combination will give me a ratio. So this green is the capacity of the section, and okay, I'll just change the display. So this green is the capacity, and this yellow portion is the load coming onto the structure. So we can see at this very end, it is outside this capacity region. Hence, we have observed the failure in the tabular format. So this will also provide you as a judgment what is the actual capacity and what is the coming force onto the structure, so you can minimize this ratio and move towards more optimum design. And for the Excel report, at the very end there is an Excel report option. We'll just click that and it will start with the Excel auto generation. So this will start. An important note over here, you should have a valid Microsoft Excel license, otherwise the Excel would not be generated. So I think it is pretty fast. So I got the Excel generated already. You can see it is in the same location where your model is saved, and it will have the same name which you have saved your model with. Okay, so we can see we have set I and J element 1813. So both these checks are provided. So we can see section properties, material properties, tendon stressing information, then transfer check. So 3-1 is our transfer check, transfer stage. So we can see concrete compressive strength stress check. It is 5.19 is below 0.6 MPa. So it is below 18 MPa, hence it is safe. For bottom of this concrete girder, again we can see top and bottom stresses, these are okay. Crack control, again it is also checked for cracking, we can refer to the clause, it is provided okay for bottom as well. Flexural design positive, so this is my factored bending moment and it has passed the flexural resistance check as well. Minimum strength requirement is also satisfied. Negative, in this section there is no negative moment, hence we have the factored negative moment is 0. And flexural resistance, minimum strength requirements, shear design for a section, again a check is provided over here. Torsional design, you can go through in detail in this Excel sheet. Also we have also released a MIDAS design guide which will help you interpret the results, interpret the clauses which these are satisfying as per Australian standard. So if you already have it, good. If not, please let us know. We will also share the MIDAS design guide for PSC design sections focusing on Australian standard. So crack check in the survey stage, we see this is failing. It means this needs an revision. NG states for non-good, not good. Similarly, we can check the I, J and properties as well. But the same values can also be observed in the tabular format. So result table, we can check crack control and we can see some red parts. It means it is failing. Okay. So yes, so that completes our actually day 1 training series, or day one training session. In about 2 minutes, we'll begin uh, with some API plugins. Until then, if you have any questions, please let me know. And yeah, so we'll begin with the next part in about 2 minutes. For those who have joined in late, maybe they can open the software and just open this model. The first plugin, we are going to use the same model. So in the drive, there is a completed model in day 1 session. We are going to use the same model to use the group pile plugin to generate the group pile plugins in this session. Okay. So I'll just set everything to initial view, close all the tabs. So don't worry, even if you don't have the day 2 training material, we are going to use it in about 20 minutes. So until then, if you still haven't received the day 2 tutorial, day 2 training material, or if you could not download it from the chat link shared above, please let us know in the chat. Eric will help you out by sharing those day 2 material. But for the first plugin, for about 20 minutes from now, we don't need the day 2 material, just this existing model is okay. All right. I'll wait for another 30 seconds. Until then, if you have any questions, please let me know. And then maybe we can begin with the first plugin, which is file group plugin. Okay, let's begin. So everyone go to this apps option. Can go to this apps option and API settings. So I'll first explain a few things about API. So this is the URL which connects to the MIDAS server. Right now, I believe there are 2 to 5 servers all around the globe for this API connection. The closest one would be Korea or the American server. So depending upon the distance, also this API speed matters. But the speed would be pretty much decent for a session for the plugins which we are observing today. So this is the URL which will connect to the server. Mappy key is the key used to connect different softwares. For the first plugin, we need not focus on this, but for further plugins, yes, you would need this Mappy key, and I'll explain them where it is required. The status currently is disconnected, so click on connect. Okay, for those who are using it for the very first time, this should be empty, so you can just click refresh so that you can have a certain value in the Mappy key. Once you have a certain letters, random letters, just click on connect and just wait for a few seconds, maybe until 5 seconds, then it would be disconnect would be inactive and disconnect would be active. It means it has now connected, and close this box. So we can also use this option to connect and disconnect, but for those who are using it for the very first time, just some detailed explanation. Okay. Once you can see disconnect, then go to plugin and click on marketplace. You can observe multiple plugins in this marketplace. Most of these plugins are very useful. You can I'll note down few plugins. So load effect for LC, it is very useful. Just note it down. You can play around with that plugin later on. Then okay, file group, this is what we are going to use today. And description of each plugin also provided once you enter that plugin, so need not worry. Load combination, breakdown load combination is an important plugin. Space gas importer, if you want to import any space gas model, is an important plugin. And those who have connected in from New Zealand, in the response spectrum generator, we have incorporated the New Zealand response spectrum code, so it can be automatically generated. Okay, so again, we'll start with our first plugin, which is group pile plugin. So spot this group pile in your marketplace and click on the group pile plugin. We can see short video of how the plugin works is also provided over here, and few information about the plugin also provided. So we'll anyways, I'm going to explain this plugin, so you do not watch it right now. You can watch it later. Right now, just click on run. Again, just wait for 2 seconds when you click on any application, because as it's connected to the server, it will take time to send and receive the data request. Okay, but before we enter this plugin, an important part for this plugin is it needs to have the local coordinates at respective nodes. Right now, we have not defined any local coordinates. So let's do that first. So let's go to node element. Go to pre-processing first, because we need to assign the node local accesses. So node element, node local access, using single select the bottom nodes. We are going to create, so this group pile plugin will create pile cap and piles beneath a pier bottom. So just select the nodes following which we need to generate the respective structures. So select the bottom nodes of your structure using the single select and click on apply. So node local accesses will be generated. We have entered these 0 values. It means they will follow the global coordinates and we are fine with it. So just select the bottom nodes, click on apply, then your node local access will be visible. Now we can go to the apps marketplace and click run the plugin. Okay. Now it says structure group. It means we need to have a structure group. All the new elements will be assigned in the single structure group automatically. So keep this box in the modeling window. You can go to the group option group in the tree menu, rank a structure group and click new, and you can give it name as pile group, and we'll select this structure group in the plugin dialog box. Same, a boundary group is required. So again, go to the tree menu, click on new and pile group. I'll give the same name to this as well. It says pile material. We are going to use the same C50 material, but pile section. Okay. So we need to also define a pile section first. So go to works tab or go to properties, add section properties, click on add and define a single pile, solid round pile, maybe of 0.8 meters diameter. And you can name it as pile and click on apply. We also have to enter a new section for pile cap. We are also going to generate pile cap. So go to the drop down, solid rectangle, pile cap. So just enter a nominal pile cap section for now, just 1 mm by 1 mm. I know this is not a practical pile cap section, but I'll explain you why we have entered 1 mm by 1 mm. This plugin will auto adjust the pile cap dimensions depending on the number of piles, their spacing between themselves, and also spacing from the edge location. And click OK. So we have defined 2 additional sections, pile and pile cap. Close this box. We still have this box open. All right. So again, to summarize, in this plugin, we have created a new structure group, provided a particular name, we have created a boundary group, and we have created a pile section and a pile cap section. Now, click on refresh because we have created these after we have activated the plugin. Therefore, in the dropdown, those options would not be present. So once we refresh in the structure group, now we have pile group. So select pile group. Okay, I think the name is misspelled, but it's all right. Boundary group, pile group, pile material. I'm going to choose C40. Pile section again 9, which is pile cap. Okay, turn on this pile cap toggle checkbox. So your pile cap options would also be activated. So pile cap material again C40, pile cap section, pile cap. Now an important thing over here regarding the pile start node. So this, although it says node, this value should not coincide with the element and node numbers present over here. So we can see there are around 4,600 nodes and around 7,300 elements. So make sure if this is overlapping the node numbers and the element numbers over here, it would give an error. So provide a different category, a higher category of pile start numbers, let's say 15,000, and pile cap, we should provide it as 10,000. So all the piles which will be created which start with 15,000 node number and 15,000 element number. If you click on auto, it would just take the immediate next node. It would give 4619. But again, as I mentioned, the elements would still be clashing because the way the script is written is 15,000 node is created and the element connecting that node also 15,000. The next node will be 15,001. Element number will be 15,001. Okay, so make sure these numbers do not coincide with any of the existing node and the element numbers. These are always a higher number, some higher numbers. Now, pile cap grouping option. So in the longitudinal, how many piles are needed? So I'm going to use the default option. So in the longitudinal arrangement, 3 piles will be provided. In the transfers, 4 piles would be generated. Spacing and cap edge. Again, I'll please hold this point. I'll just explain this in some time. Unit length. So this unit length. Okay. So first enter, we'll just enter this as 0.8. Pile length is, let's say 10. Now, and pile height, let's say I'm assuming 2 meters. Okay. Now, this unit length and spacing needs to be understood in altogether. If the unit length is D, it means this is a multiplication number. For example, this is the pile spacing in longitudinal direction would be 2.5 times of pile diameter. Unit length D, it will represent diameter. 2.5 times of pile diameter would be the center to center spacing of piles in longitudinal direction, and in transverse it will also be 2.5. So 3 piles at 2.5 times diameter spacing will be created in longitudinal direction, and 4 piles with 2.5 times diameter will be created in transverse direction. And the cap edge, the face of the pile to the edge of the pile cap would be 1.5 times of the diameter. So if we have selected D, this is this is a multiplication number with respect to the pile diameter. So spacing will be 2.5 times of diameter and the cap edge would be 1.5 times of diameter. But if we have selected length, now this is no more a multiplication number. This is the unit number. So the spacing of the pile would be 2.5 meters center to center of the piles in longitudinal and 2.5 center to center in transverse. Now this is no more a multiplication number. It is a unit number. And as I mentioned, we have entered a pile cap dimension as 1 cross 1. By following these rules, that dimension of pile cap would be automatically updated such that it also satisfies these rules. So enough explanation. I think we can begin. We'll generate a pile cap quickly. An important thing, this function will only work for one node at a time. We cannot select multiple nodes and expect it to generate pile and pile cap. So we'll use single select. I'm just using this corner node and click on create. It will give me prompts to confirm the values and click on create. As I mentioned, it will take some time to generate. And again, since the model is too big, there are almost 2,800-ish tendons. Hence, this is also one of the issue that this might take some time. But don't worry, all the further plugins, we are going to use smaller models. The same plugins would be applicable for this big model as well. But as I mentioned, it takes some time to generate things. Therefore, it will not be feasible to explain these plugins in a big model, and that too in a training session. But I have personally checked these plugins will be still valid for a big model as we have on the screen. Yes. So we can see it will create a pile cap and also the piles. Let's check the pile cap dimension first. As I mentioned, it will be auto adjusted. So it has auto adjusted to 8 and 10.5. This we have entered previously as 1 cross 1. And if we observe the distance of the piles, so this first node, second node, the distance is 2.5. As I mentioned, since we have selected length, it is using this as unit parameters. All right. So if we add this up, 2.5, 2.5, which is 5, 1.5 from the center to the edge, 1.5 from the center to the edge, sum adds up to 8 meters. And we can see one of the dimensions is 8 meter, and obviously other would, you have to just add 2.5 because there is just additional pile in the other direction, therefore 10.5. So software will auto adjust the pile cap dimensions. Now let's do one thing. We'll try to use the D option over here. So again, there is this undo option. Got it. Need to check in create pile cap. Yes, if you need to create pile cap, you need to check this on, or else it would just ignore the pile cap and create the piles with a master rigid connection. So if I just look at the master slave connection, so we can see after the pile cap is created, so this element represents pile cap, and then from the bottom of the pile cap, the piles are created. If you do not check on the pile cap option, your piles would be directly created at excluding this member. So at this height of bottom of the pier location. Again, plugins will, there might be scenarios that you might be able to do this faster than the plugins, but there are, these plugins are used to address specific problems. There are clients who are facing to generate these kinds of models as well. So with these plugins, we can just help with quick generation of the models. Okay, now let's do one thing. We'll try to use the D option over here. So from the undo box, I'll just undo until all the 10 commands, because software has used 10 different scripts to execute this function. I'll just undo it. So it is all empty now. I'll just switch it to D and I can click on create. Even if you could not perform it in today's session by following me, it is completely all right. It is expected that you try it on your own, because once you do it on your own, look out for every option, then you can have better understanding of the plugins. Okay. So now if we look at the values, let's say the spacing. So 2.5 times D would be the center to center spacing. I'll just go to query. I'll check the spacing of the piles. It is 2 meters. So 2.5 of 0.8 is 2 meters. Therefore, the spacing of the piles. And edge distance would also be the same. So let's say 1.5 into 0.8 is 1.2. 1.2, 2, 2, and 1.2 would give me around 2.4 and 4, 6.4. And now we can observe the pile cap. So it is 6.4, which is 1.5 times 0.8, 2.5 times 0.8, 2.5 times 0.8, and 1.5 times 0.8. Okay. So this was all for this plugin. Again, I'll wait for a minute or two if you have any question with respect to this plugin, because again, as I mentioned, there are a couple of other plugins in the marketplace, but our agenda was to showcase this plugin because we understand Wizard is just generating model until the peer. But if we need to generate a complete model with pile cap and piles, then you can use this plugin and complete your entire model. So this plugin was selected such that we can align with the present session's workflow. I'll wait for a minute or two for everyone to complete or to check out this plugin firsthand, and then we'll move on to the next plugin. Again, I do understand that there is overlap and they should not behave this way, but again, the agenda for this plugin is to show how it works, and we can obviously edit the parameters and apply the same application somewhere for a complete model where we don't have these many closed peers at distances. Okay. Pile cap grayed out. Have I missed any step? Okay, you have to check on that pile cap, I think. Oh, but I think I will answer it. Could you also assign training materials? Training materials. Okay. All right. Let me know if anyone is facing any issues. Unlike yesterday, we have some free time in today's session, so we can discuss those issues during the session as well. So don't wait until the end. Please let me know. All right. So I think everyone has a higher idea of how to generate this, and they have tried to generate at least once how the pile cap and the piles would be created. You can also observe the various groups which we created. They have the respective elements included in them. So I wonder if the plugin can create the pile cap connecting. I think what you're referring to, you want the pile cap to connect all of these columns. So the answer would be no. The reason is, as I mentioned, the plugin is created to address a particular issue. Usually, if we need to create the pile cap to connect these plugins, it would be a beam element. So in this, if we just turn on the hidden view, we can see it is created the pile cap as a column element. So that would not be the case. And this plugin follows this particular script or procedure to create the pile cap, but it cannot create a pile cap connecting all of these peers. We have to do it manually. Yeah. Also, an important thing, if you feel that a particular plugin will be widely used by your organization and but you need some more modifications in the plugin, all the plugin scripts are available freely on GitHub. If you are interested, send us an email. We will send you the scripts of the plugin which you are interested in, which are uploaded in the marketplace by MIDAS. So we will share you the script. You can modify that script further to meet your own requirements. But for every plugin, we have clearly mentioned some limitations and their strengths and the procedure of working. And it will be very helpful to understand if you want to proceed ahead with using that particular plugin or not. So all the scripts of the marketplace plugins are provided, are free to use, free to modify. Obviously, not modify on the website, but you can copy it in a local drive and then modify those to meet your own requirements. Please send the design guide, and okay. All right. So I think we have spent pretty much time on this plugin. Now let's move on to the next plugin. I was still waiting. What does this error mean? Okay, let me check. Okay, it means the very first step you have missed. Very first step, you have not defined the local coordinates for those nodes. So we have to define the local coordinates at the node which trying to select and then generate the plugins. So for example, yep, I think you understood. So just create local coordinates, node element, node local access, select the nodes where you want to generate a local coordinate, just press apply. Need not change anything over here. You need not close the dialog box, just move that dialog box aside and generate the local coordinates. Otherwise, if you close it, you need to re-enter the details. All right. Okay, now let's move on to the next plugin. So we have, okay, two plugins to move forward with. We'll first try out the uh, PY curves plugin. So I hope everyone has received the training materials. If not, Eric is working on it. He's sending those one by one. But for all of the others who have already received the training 2 materials, we are going to use the PY curves automated plugin now and see how it works. So there is a model in the folder. Please open that model first. Again, we can use those plugins with this model which is on my screen. It is not limited or it is not catered to one specific vessel. But since this is a big model, there are few rules which I would like to mention. And in order to satisfy those rules, we need to make some modifications in the model and it would take some time. Hence, we are going with a preset model. The agenda for this session is just to understand how the plugin will work and not actually implement it on a real structure. Implementation on real structure is always possible once we understand how the plugin will work. Okay, so I hope everyone is able to open this model. This is a simple example of a substructure. I believe this is one of the sections of metro sections where the station is placed. This looks like a pre-stress slab, a pre-stress pier cap, and yeah, top cap. Okay. Now, once we open the model, we also have to open the Excel script. So before opening the Excel script, right click on the script, go to the properties, and there would be a highlight over here to unblock the particular contents. Since we have going to use macros, if you have downloaded it from an online source, this Excel sheet will automatically be converted into a block mode. So there should be a unblock option once in the properties option for the Excel script. Please unblock the Excel sheet first. Because if the Excel sheet is blocked, we cannot execute the macro function. Hence unblock the Excel sheet. I have already, since I have shared the files, I cannot view the option, but in your system, if you have downloaded from a website or from our own link, you have this, you should view this unblock option over here and just unblock it, check on unblock and click OK. Sweet. Once you do this, just open the Excel sheet right away. So this is the model and the Excel sheet. If you're using multiple screens, you can place these in different screens or else just place these side by side in the same screen. I'm taking a few pauses so everyone can perform this step. Since the API is new to the market, this might take some time to be used to. Therefore, I'm going slow with these API parts. Okay. Now, before moving on to the plugin, there are a few guidelines which we need to be careful of before using any plugin. Okay, let's see the issue. Not able to access MIDAS model. Um, I think, Ali, this is something to do with the protection ID. Are you using the protection ID which is shared in the chat room? This has yeah, something to with the ID which you are entering, not with, you are not using the ID. And is this civil NX or is this civil? Because yeah, plugins will only work with civil NX. These will not work with MIDAS Civil because API functionality is available only in MIDAS Civil NX. So if you already have Civil NX installed, I would recommend to Civil NX and open the model. If not, maybe you can just have a look at it and install Civil NX later and try out the function itself. We have the protection ID which is provided, that is a free trial for Civil NX as only for this training series. It is valid, I think, for a week. So maybe if you haven't installed NX, you can install it and try out the protection ID for a week and try out these plugins yourself. Okay. Now let's okay, I was in the explanation for the guidelines of how to use these plugins. So every plugin, as I mentioned, is created to address a particular problem, and there are a few set of rules which were assumed to create the logic of the plugin. So we need to follow these rules. So the very first rule is follow the sample input format while creating the force deformation function. So in this, to the right hand side, this is a input format which is provided. We should provide a depth of every depth. The force deformation function will change. Therefore, we need to provide this particular syntax. We need to provide values particular syntax only. So whatever depth you go to, you have to follow this particular flow chart. Then second rule, ensure there are no missing node element numbers in the model. Example, highest node and element number should be equal to the total number of node and elements in the model. Okay, I'll explain what this is. So let's say we go to the node elements, nodes and tables. These are the node numbers. So we can see there are no missing node numbers in the model. So let's say all the node numbers. So the total node numbers and the final node number is the same. If there are any missing node numbers, let's say I have skipped node number 79, then the plugin will not work. You should make sure that the total node numbers and the element number are the same, because in this plugin, we are generating the force deformation functions, also creating the piles as we generate these force deformation functions. And when piles are created, new node numbers are assigned. So it will pick the node number which is missing in this sequence as the first node. But when it tries to create a second node, it cannot have that node number because it is already occupied. So if there are no missing node numbers, it would automatically pick node number 102 as the very first node and then subsequently create the further nodes. Same is applicable to elements. Therefore, make sure you do not have any missing node numbers as well as element numbers in our model. Okay, that was the second rule. And third is model should not contain any force deformation function before using this plugin. The same is applicable for force deformation functions. If there are force deformation functions present in the model, then it would not behave accordingly. It means whenever these force deformation functions are sent to the model, it would always start with first ID. If there are any existing force deformation function present, then it would be clashing with the script and it would not give any output. Okay. So we'll start placing this side by side, and first there are two steps in this. First we create the PY curves, and second we create the piles. And while these piles are being created, software will automatically assign these PY curves at respective depth. For example, this PY curve property is for depth 0. This PY curve property is for depth 1, 2 meters, 3 meters, and so on. So again, go to apps, API settings, copy this mappy key. Now this is not an external internal software we are dealing, this is an external tool. So copy this mappy key and paste it in the mappy key tab. Everyone will have a unique mappy key, because if this mappy key would be common, then it would not have it would not able to decide which software to access and how the data should be exchanged. Everyone will have their unique mappy key. Make sure you copy your mappy key and paste it in the mappy key tab in the Excel spreadsheet and connect it. So right now it says disconnected. It means it is already connected. Okay. Once you have pasted this mappy key, now you can click on create PY curves. Click on this button. The macro will be executed and force deformation function successfully imported. In the tree menu, we can have a look at the force deformation functions. So we can also see the name. It has provided the same name which we have provided in the Excel sheet. So besides depth, besides this blue column, it will check this particular row, column B, it will identify depth and it would make a note, okay, this is my force deformation function. So this is the logic behind this plugin. So depth 0, if you look at the properties for depth 0, we can see the same chart which we can see over here in Excel sheet in the MIDAS software. So 3.315, 1703, 136, 0.315, 1706, 136. Similarly, even if your force deformation function soil layers are changing at an intermediate depth, let's say depth 8.4. So this acts as a dual way. So it also states the location where this particular PY curves is acting. So when we are going to auto generate the piles, we can identify, the software will automatically identify to assign this 8.4 meter depth property to that respective location of 8.4 meter along the pile length. Okay. So I hope everyone was able to generate the force deformation function. If there are any issues, please let me know. I'll wait for 30 seconds, then I'll move towards the second step for this plugin. All right. Now let's move on to the next step. So next step is we are going to create piles and also automatically assign these force deformation functions at the respective depths. So first, in order for software to identify which node, which function to be satisfied, we need a reference node. So we can see reference node is 7. So I'll just turn off this view so we can quickly identify. So let's say we are going to basically choose a datum. And if we select this, it is okay, some other nodes selected. We can see node 7. So you can enter node 7. It is already pre-entered, but for your own satisfaction and to understand how it will work for different nodes, we can enter 7. Now second, top pile nodes. We need to select the top nodes of pile from where we need to extract the piles or from where we need to draw the piles. So I'll just move this, select these nodes and these nodes. So 4x3 arrangement. And again, we need to enter the same node numbers in the Excel sheet. So we can copy this entire thing, Control C, and in here, just Control V, copy and paste. So from these 12 nodes, your piles would be generated and the force deformation functions would be assigned at respective depths. Third is pile material ID. As we know, if piles are created, we need material ID and section ID. So we will just refer to the ID. So I need to enter M40 grade. Some different country code is used, therefore it is M40. So, but it is fine. So ID is 1. So you need to enter ID as 1 and pile section ID. We have defined our pile section for 5. So we can enter 5 over here. And once we have entered all of this data, we can simply press create piles. I'll just turn on the 3D view. So yep. Okay. Once we click on create piles, please wait while this command is being executed. Do not interrupt or click anywhere because currently software is executing a command. If we click at any point in the model, the command code will be disrupted and the execution would be terminated. A dialog box will pop up once the execution is complete. Just creating the 11th pile and finally the last one. Okay, it has given me a pop-up, pile successfully created. Now we can see these nodes are generated at the same locations according to this depth. Because if the nodes are created at equal spacing and there is no data of force deformation function at that particular spacing, then it would be an issue. Software could not extrapolate or cannot extrapolate or interpolate between force deformation curves. Therefore, it is scripted in such a way to allow the nodes to be created at the same locations where we have our force deforming functions. So in this, we have force deformation functions until value 20. Therefore, this is the position of force deformation function at the very last node of this pile. So we can also observe that. So let's observe the node number first. Node number is 124. And if we go to multilinear spring tables, observe node 124. Node 124. Go to the right hand side. We can see number 20 force deformation function is assigned to X as well as Y direction. So it saves a lot of time in manually creating these force deformation graphs and then assigning these force deformation graphs to various depths in our pile locations. So I hope everyone is using this plugin with their own system and they were able to successfully generate the piles. If there are any issues, please let me know and I'll try to resolve their query. Okay. If you want to access the script of this particular plugin, then you can go to the developers tab. You can go to Visual Basic. Visual Basic will open up and you can see the PY curve. So this is the script for this particular plugin. This script is a completely open script. You are free to modify the script further, make any changes according to your own use case. Set units, set node element, get data, and update the data as well. So by default, VBA does not have a JSON converter. As I mentioned, in order for the API to be useful, we need to convert them to a JSON syntax. So by default, VBA does not have a JSON converter. So this JSON converter is provided so that whatever VBA scripting we can do, it will automatically convert it to JSON syntax and then executed via the API. Okay. I don't know, is the MAPI key automatically generated by Excel for each use, or do we have to modify the MAPI key manually? We do have to modify the MAPI key manually, because this MAPI key, when we shared it, I think I was working on the plugin, so this MAPI key would have been mine, but I have refreshed it. So make sure you enter your own MAPI key, which is observed in the Civil box. So you just go to apps, app API settings, and copy this MAPI key. So this MAPI key is a unique key for everyone. You can consider it as a temporary password. So this will help you connect it to the Excel sheet in your own system. Yes. So once you paste the MAPI key, you can click on create PY curves. Curves will be generated, and just click on create piles if you want to quickly generate the piles. And I've already explained these inputs over here. I'll wait for 2 more minutes. Then if there are no questions, we can go for the next plugin, which is debonding lens plugin. After the plugin, again, we would have a short Q&A. If someone wants to unmute themselves and discuss something, then we can have that session after the at the end of today's discussion. If you're facing any issues, please let me know. I'll try my best to resolve them. I will wait until 120, 1320, and then I'll move for the next plugin. Until then, please try out this plugin couple of times and then let me know if you have any other questions or doubts. Miss other I missed the explanation reference node, how it is defined. Okay, so reference node helps the software or the plugin determine at which node it should assign the respective force deformation function. So in this model, I have selected this node as the reference node. So 7 number. So you can consider this as a datum. Following this, along the length in the uh, downward direction, it will create the piles and also assign these respective force deformation functions at respective node locations for the piles. So you can consider the reference node, and this will act as a reference to assign these force deformation functions along the length of the piles. Okay, I think it's, yeah. Yep. Now let's move on to the next plugin, which is the debonding length plugin. For those who could not finish this or want to try once more time after the session, in the same materials, we have also provided a video of similar thing which what we demonstrated, what I have demonstrated. You can watch this video and perform the same steps, and you will understand how the plugin will works and how it is implemented. All right, now close this and open a new model. So we have shared another plugin in the training material called as Debonding Made Easy. Now we are going to use this plugin. This will be a last plugin for the session. And yep, then we can have Q&A and then wrap up. So open the model which is shared in the Debonding Made Easy plugin. Right. Now in this model, yeah, we have two sections. So the first section is the section which we used in our training session, Queensland section, the TMR section, sorry. And the second is a Super T section. We'll try with both of these sections to see how the debonding plugin will work. So Debonding Made Easy plugin is used to define debonding lengths in our model. In any scenario, when we have a project, we usually take a simple beam and then try out various debonding equations, try out various debonding options with a simple beam. Once we find our appropriate debonding lengths, which also satisfy the transfer state check, then we apply that in a full scale model. Idea is similar over here. These are the few simple models which we have generated. We will see how the debonding plugin works and how an engineer can incorporate it when he wants to finalize the debonding parameters in his model. Again, the same thing will also be applicable for the large model which we have created in our session. Just it would take some time because it is a pretty big model. There are around 2000 tendons in it. So it might take some time to play around with all the to execute the function, but it is applicable to a large scale model as well. Okay. So I hope everyone has this model in front of the screen. Again, for the Excel sheet, again, this plugin is created with help of a Excel macro. Again, right click, properties, and unblock the particular file. Since I have downloaded from an external source and not opened it, you must see the unblock option. So just check on this unblock option, which will be highlighted over here. And once you do it, open the Excel sheet. Okay. First, I'll explain quickly about this model. Okay, so there are a few tendon profiles. I guess only the tendon profiles are important here because we are going to update the debonding list for the tendon profile. All right. So these are various tendons in the model. These tendons are auto-generated from the software. So we can see the elevation view, various tendon locations and their respective names. So some are at the top as well, and similar for Queensland. Now we will extract this tendon layout in the Excel. Again, first we would go through the guidelines of how to use this plugin. Very first rule, plugin scope is valid for straight tendons. It means it is only valid for precast units. Even if you try to use it with parabolic tendons, there might be some issues in the software interface of these of this plugin, because it is assumed that the tendons are straight. Because the tendons are straight, they would have, these tendons would be located in the same position for first element, for middle element, and for the last element of a particular section. Their position would not change. But if it is a parabolic, then there are various different locations of tendon. The tendon might be in the top, in the end, it might be at the bottom, in the center position. So then it would be difficult to map the tendon location. It would not give us a complete idea. Therefore, the plugin scope is valid for straight tendons. Start and end debonding lengths are assumed to be similar. Whenever we are going to update a debonding length, software will automatically update the particular value of debonding length at the start and at the end of the tendon. Right now the scope is limited, that the debonding length would be common, because only a single input will be provided to update the start and the end of these tendons. We cannot have separate debonding lengths when we are trying to use this plugin. Just two rules for now. Okay. So now first let us understand which element we want to extract the tendon layout of. As I mentioned, different elements might have different tendon layouts. In case of straight tendons, it does not matter even if we choose any number. But again, in terms of parabolic, it matters. And therefore, please make sure the tendons are straight, or else the plugin would not be as useful as it should be. So let's identify, since it is same, it does not make a difference. Let's say 11, we'll choose 11, enter the element number in this yellow box. Oh, but before that, we need to make this connection. So make sure you connect the MAPI key over here as well. So copy and paste the MAPI key in this box. Okay. So we have pasted the MAPI key, the connection established. Now is a bit difficult. Okay. Click on get tendon data. Currently the number of tendons is 0. We have just entered the element number in this case. Click on get tendon data. Okay. Now we can see we have obtained a grid. Okay. I think I'll just show it like this. Grid format of the tendons. If we just focus on few starting ones, that would give us an idea. I can go to properties to view the tendon layouts. So let's say we are in Super T element 11 and tendon. So we can see this is the same number. For example, 47. It is highlighted 47. So at the very top it is 47. The next row, and this is A and 1. Next is 45, which is a row below it. So T45. Then T33 to the right of T30 with T35, T33 to 35. So it has mapped the same location of tendons as in the section provided in the section. We can obviously cross check for other location as well. Now, the first table provides us with the name of the tendon, and the second will give us input boxes to provide the debonding lengths. For example, let's enter for number 1, let's say 3000. Another rule is debonding length values which are provided over here are always in millimeters. So even if your civil software says it's meters, or it says millimeter, but yeah, if it is a different unit, then these values should always be entered in millimeters. Okay, 3000 is somewhere else over here. Sorry, 3000. And obviously it is understood that these values should be provided in symmetry. But just for now, since we are trying to learn how the plugin works, we'll enter some unsymmetrical data. So 001 T013, let's enter 2000. And another one 39 will enter maybe 1500. So 1, 3000, 13, 2000, and 39, 1500. After this is conducted, we will just update the bond length. Update the bond length. The buffering has stopped. Now we can actually view. The debond length can also be identified if this different notation of tendon layout is observed. If there is this dashed lines, it means that tendon is debonded until a particular length. So this also states the debonding zone. So we wanted to check T1. So we'll just check properties and we can see in the debonding length 3000 is entered. There are various rules which an engineer follows to debond a particular length. Couple of rules which suggest that not more than 60% of the tendon should be debonded in a single row. Adjacent debond strand should not be debonded. We can follow our own rules and provide the inputs over here. So let's check for T13. We can see 2000 start and end both, and finally T39 1500. Now let's say we have entered certain debonding lengths in the software. Can we extract those debonding lengths over here? Absolutely. So for example, let's check for 45. I am providing some debonding value of, let's say, 4000 and 4000. And I'll click OK. I'll click on empty data and I'll click on get tendon data. So we can see at T45 4000, and as for the other locations the same, T2 and 1500. It will also tell me the number of tendons present in that particular section. So 48 tendons are present in this element 11 section. I hope everyone has got an idea how the tendon debonding plugin, Debonding Made Easy plugin works. Now please try it on your own. Choose some element number for the top sections. Let's say data, let's say element 40. Cancel. Element 40 and click on get tendon data. You can have the tendon mapping for this element 40 tendon layout. Procedure is the same, provide some debonding values and update it in the software. Okay. The scope of these plugins is much more. For example, this plugin can be further enhanced by obtaining the stress diagram in the bottom of the Excel. So you need not change this data. You can just observe the stress layout in the same Excel sheet, so you can identify the critical location or the critical stress checks at the transfer and at the complete stage. So we encourage you to modify this script further, modify these plugins further so that they will be used for your own use case. Again, the script of this plugin can also be viewed in the same Excel spreadsheet. In the developer mode, you can go to Visual Basics, and in the module, you can see Debond ME, and this is the script for the plugin. And nowadays, due to all the AI tools, ChatGPT and other tools, you can paste this entire script in ChatGPT, tell ChatGPT to explain you the complete script. It will give you a complete description of how the script works, and also by training the model by few prompts, you can also get an output to modify the script. So with these tools, it is now pretty much easy to create some small plugins which help us in tremendous time saving. All these plugins are created by engineers like me within MIDAS. These are not created by any developers. So you could understand how easy it is to create few plugins, and which will help us in saving a lot of time in our day-to-day tasks. We are almost at the end of our session. Now we can have an open discussion. If anyone would like to unmute themselves, discuss anything, ask any questions, share their screen, please feel free to do so. because yeah, we will conclude the session exactly at 2 o'clock. We have 25 minutes to try this out on your own. I'm available online. If you face any difficulty, please let me know. I'm ready to help. But yes, for everyone who has uh, joined the session and who are just observing, please, you can the session, we can consider the session as concluded, and you can get on with your other task. For those who are still trying the plugin, please stay, discuss your issues with me, and hopefully we can resolve it within the session itself. And yep, thank you everyone for joining. I hope this was insightful. You could try the plugins firsthand and also use the updated features like the Queensland database section, B double vehicles in yesterday's session. Please fill out the form which Eric has shared so that we would be able to plan much more training sessions, interesting training session depending upon the topics which you have requested, which will benefit you uh, to use the software and which will be implicable for your current projects as well. So thank you everyone for joining, and yep, see you again. I'm still here until 2 o'clock. If anyone has any questions, please let me know. We can discuss those and move ahead and then conclude the session. Eric, if you have anything to say, yep.
I mean, yeah, as Pranav mentioned, there will be a satisfaction survey within an hour, which will be sent at, as far if I'm not mistaken, 1 p.m. 3 p.m. as a Sydney time. So that'd be great if you do a survey, and then we're looking forward to getting any kind of feedback, and then we're gonna tailor the next online training session based on the feedback from you. So that'd be great if you take a time to do a survey, and we'll be here until 2 p.m. So you can ask us any question if you want, like whatever you want.
If you have to provide any feedback by unmuting yourself, please, you're always welcome.
You're always welcome.
So can we unmute them? I think we have.
I think they can't unmute themselves unless we
No,
can.
no. I think we have to allow to unmute.
Right, right. Or you can leave us a chat and we can answer that.
Yep.
So since there is almost 40 people here, so I don't think I can unmute every single person. So you can leave us a chat.
Yeah, let
and
us
then
know
we
in
can
the
answer
chat.
that. Yeah, that'd be great. And just a quick reminder, there are some people who want get a PSD design guides as per AX5100. So I'm gonna send them all together after the training, so you don't have to worry about it. Well, I think there is a question from Lu Yuan. So can you answer that, Pranav? Pranav, I think you're on mute.
Sorry, yeah, I was on and I was reading it. Okay.
Yeah.
Say we have 20 girders per span. To create debonding plugin for all the girders, do we need to select one element per girder and repeat the process 20 times? Yes, Yuan, that's correct. So you have to select any element from a particular girder and then enter some debonding lengths and then update it. So automatically update it to that particular span tendon, that particular girder tendon, and repeat it 20 times. Your understanding is correct.
Thank you. Thank you. Appreciate it, Pranav. Yeah, and also just a quick reminder, as I mentioned, I think I mentioned yesterday, but the training session will be there is some people who wants to see the training session recorded video, so I'm gonna send a link in a week. So please check your email box in a week.
Thanks for the presentation. Is it possible to use implemented PY curves plugin for varying ground levels? Example, that is a bridge structure spanning over a river bed with varying ground level heights, or is it limited to constant ground levels across the structure as reference node is fixed? So we also can use it for varying ground level, but the plugin for this, the scope of this current plugin is fixed to a single reference node. But if your force deformation functions at that respective depths are same, then you can choose a different reference node, arrange your force deformation functions according to that node, and even if the corresponding nodes are at variable depths, it is possible. So let me explain what I'm trying to convey. Only point here is your PY curves should be same for at respective depths. So even in this scenario, if I have selected a reference node as this node, just hypothetically, and I'm trying to generate piles from these nodes, until this point, there would be no force deformation functions, but starting from this reference node, force deformation functions would be assigned at that particular location. So your reference node is constant. You can select multiple nodes with various ground levels, but at a particular level, your force deformation function should be the same. Kiran, let me know if that was sufficient or you need to explain me further. Okay, let's do one thing. I will explain you how this could be done. Just delete it. I'll give you a demo. That would be much helpful. Okay. So now in this, first I'll connect it to the API. Close. Now reference node is still this 7 number, but in terms of, I'll just select few nodes so that it will take less time. Let's say at a very far location, since this is just an example, let's say there is a different, it is a single span bridge. These are right hand side nodes, and this is the node at the left hand side, which the ground level is different, but I'm selecting the same reference node. I'll copy this values. I'll paste it over here. Okay. Reference node is this provided over here. These are right hand side span nodes, and these is nodes at the left end of the span. I'll click on create piles. So if we observe, it can use the same reference node, but at this location, it will provide the force deformation function of depth 0. At the same level, the same force deformation function would be provided. But even if you choose which is not in the same zone as the reference node, it will create a pile and also assign the functions, but the function is assigned following the reference node. If we look at the node number over here, 148, it should have assigned 148, 3 and 4 should have force deformation function 0 assigned to it. Okay, I think there was some issue. Okay, we did not create the force deformation functions before creating the piles, hence there are no force deformation functions. True. Curves generated, and then we'll create the files. I'll just use a single one, 4 and 25, not multiple files. Okay, so we look at the values of 125 and 4. Okay, multilinear. So 125 will be provided force deformation function 0, and 4 will also be provided force deformation function of 0. That means even though you select nodes which are not in the same correspondence as the reference node, same plane of the reference node, it will still work if the nodes are top and at any location. But considering your property of py curve is same at every particular level. So if that is okay, you can use this function, or else we need to modify it further to have varying reference node and varying pile nodes to be created. I hope this explanation is clear. If you have further follow-up questions, please let me know. Nice session. It seems that everything we can do in Civil can also be done in Civil NX. Yes, that is correct. Moreover, Linux appears to offer additional options for optimizing model and result extraction through the use of API plugin. Yes, absolutely correct. Thank you, Ahmed. Okay, all right. Thank you. Thank you everyone for joining.
Thank you, everyone. Thank you. So it seems like there is no more question. So I think that'd be better to wrap up a bit earlier.
All right.
So you can ask. So if you have any question later, do not hesitate to reach out to us through the our official email or my personal email. I'll leave it in the chat. So really appreciate your participation and looking forward to seeing you all at our next event. So is there anything you want to say, Pranav?
No, it's all right. You can wrap up. Thank you, everyone.
Yep. Thank you very much. Thank you, everyone. See you next on our upcoming event.